Hello, welcome to our lesson of today where we continue on logarithms, and today we are going to discuss antilogarithms. Maybe the first thing we need to understand what we mean by antilogarithms. We have already seen how to obtain logarithm of numbers, either numbers greater than 10 or numbers less than 1. If you are given the logarithm of a number and you want to know the number whose logarithm is given, then you use the antilogarithms in getting the number. So antilogarithm is a reverse process of getting the logarithms. So by using antilogarithm tables, you are able to know the number whose logarithm is given. And I want to bring your attention to, again, our mathematical tables, that you find a column of antilogarithms. Just after the column on logarithms, you have the column for antilogarithms, and that's the one you're going to use in finding the numbers whose logarithms are given. So we have said that antilogarithms is a reverse process. This is the reverse process. The reverse process of finding logarithms is a reverse process. Is a reverse process of finding the logarithms. So through the antilogarithms, we are able to obtain the number whose logarithm is given. So we are able to obtain the number whose logarithm is given by use of the antilogarithms. And we are going to maybe take one or two examples for us to understand this. Maybe you are asked find the number whose logarithm is, and you are given 0.6107. Another way that this number can also be expressed is 10 raised to 0.6107, because that's a logarithm for us to find the number. Now, to approach this, you realize that this logarithm, we have said it has two parts, the characteristic and the mantissa. And you realize that our characteristic here is 0. So what are we saying? A certain number a times 10 to power 0, which is this, has the logarithm of has a logarithm of 0.6107. So class, at this juncture, you take the mathematical tables and read the antilog of 0.6107. It is well indicated in the column. You go down to the point where you see 0.61. 0.61 is given 0.6107. Moving to the right up to where 7 is, then adding that digit to what you have, then you'll be able to get the antilog of 0.6107 as 4.074. So meaning our A now is 4.074 because the antilog of 0.6107. So we have 4.074 times 10 to power 0. 10 to power 0 is 1. So it means 4.074 times 1, the answer is 4.074, meaning the number whose logarithm is 0.6107 is 4.074. So through that, you are able to get the antilog. You are given another question. You are told, evaluate 10 raised to bar 2.3031. So when it's written like this, class, it's up to you to know that bar 2.3031 is the log of a number. So what is that number? Because that number whose power is bar 2 is the one we are looking for. And therefore, the process is the same. We take the log, which is bar 2. We can say this is a log. The log is bar 2.3031. And we start reversing. A certain number A times 10 to power what? This is bar 2. So to power negative 2. So a certain number times 10 to power negative 2 gives us the log bar 2.3031. So the next step is to look for the antilog of 0.3031. If you check the antilog of 0.3031, you realize that it is 2.01, which is therefore our number A. 2.01 times 10 to power negative 2. Now, if you remember, class, when you are discussing the laws of indices, you are able to see that 10 to power negative 2 can also be written as 1 over 10 to power 2. So this is therefore 2.01 times 1 over 10 to power 2. And 10 to power 2 is 100. So we are saying 2.01 times 1 over 100. So to simplify this, you realize that these are two zeros that will take care of two decimal places, and already we have one decimal point, which is 2, so you're just going to add another 1. So this is going to be 0.0201, and therefore the number whose logarithm is bar 2.3031 is 0.0201. And maybe we can have a few more examples in the next lesson. But I want to believe that from this you cannot be able to use antilogarithms to know the numbers whose logarithms are given. Thank you for your attention.